Hi, everyone. I'm Albert. I'm from VMRay. I'm really glad to be on stage for Virus Bulletin. This is my second time already, but the very first one was during the COVID era, so I had to do the remote online version. So I'm really glad to be finally here physically. So today's talk is about Latrodectus loader. It's a malware loader, and I want to give you an all-around introduction to this malware family. I'll give you some details about it, the insides and the inside out of the full malware. So let's start. Latrodectus was first seen in October 2023, caught by researchers. You could classify this malware family as a loader, downloader, and partially a backdoor as well due to some of its functionalities. The final payload of Latrodectus is a DLL-based payload, usually with 4 exports, all pointing to the same export address, which is an interesting technique. The threat actors that basically use this malware family first were TA577 and TA578. These are the guys that are known for the Quackbot and also the IcedID malware. Basically, Latrodectus is sort of a substitute for IcedID, since research suggests that there are some strong ties in the infrastructure of Latrodectus and between IcedID. The malware loader has similar functionalities and similar modularity to Picabot as well, and it introduced some interesting evasion and anti-analysis techniques, like there was this inclusion of a self-deletion POC script. It leveraged hashed APIs, and also it featured encrypted strings. All right, before all the nitty-gritty details, I want to give you a high-level overview of its versions. So the very first one, version 1.1a, we named internally, was featuring a XOR encryption with a PRNG function. And the next iteration of Latrodectus was basically introducing a downgrade, where it removed the PRNG function and just simply switched to an incrementer. And now it's using a rolling XOR for encryption. And soon after that, it was releasing new subversions. Then came July 2024, where it introduced another encryption scheme change. The rolling XOR was changed to AES encryption in CTR mode. And also this version, version 1.4, introduced new C2 commands as well. And so Latrodectus was still seen being developed. And we get to 2025, where it's now version 2.x. Again, new C2 commands were introduced. Let's look at some of the delivery techniques that this malware loader uses. The very first one, and the early versions of Latrodectus was first seen being distributed via phishing emails, often leveraging a DocuSign-themed alerts, where basically the victims were enticed to click on, for example, this review document button, and then it would take the user to a malicious obfuscated JavaScript with tons of commented lines. And here and there you would see actual code, like here there's a slice operation or this sub-str function. And these are basically assembling the final plain text JavaScript, which is pulling an MSI file from a remote server. Mostly these MSI files are legitimate installers of very well-known programs, but they are sort of backdoored in a way that the Latrodectus payload, or the DLL, is embedded inside of these MSIs, and the custom action launch file parameter is used to execute the DLL once the MSI is also getting executed. Now, recently there's been a change in delivery. We've seen this interesting new technique where vulnerable websites were injected with JavaScript, and this JavaScript is basically displaying a iframe overlay over the legitimate website. Now, this iframe consisted of a Cloudflare captcha and the technique we all know as click fix. And once the user basically copy-pastes this command and executes it, it downloads a JavaScript file again, and this JavaScript file is connecting back to a Telegram channel. where a bot is sitting and receiving instructions, and it can also send instructions. And in this JavaScript, we found a constant which is pulling the Latrodectus payload itself. I want to cycle through the evasion techniques that we captured with this family. The very first one is the process count check, which is, I believe, is aimed at sandboxes and automation. The family is using RTL get version and get version EXW API calls to grab the Windows operating system's version, and based on that, deciding, for example, if it's a Windows 7, 8, or 8.1 version, then Latrodectus needs at least 50 processes to be running in the background. If it's Windows 10 or 11, it needs 75 active processes. So this is mostly aimed at sandboxes. The second interesting evasion technique, it's using the get adapters info API call in Windows, and just walking the IP adapter info structure, finding the address length of the MAC address, which is, again, here, in this case, comparing it to 6. We all know Ethernet has been standardized for ages, and it's a 6 bytes length of a MAC address. So we believe, and I also believe, that this is aimed at some really edge case scenarios where the MAC address is really not 6 bytes long, or even doesn't even exist. The third one, I would say this is pretty much a standard technique nowadays. The Latrodectus sample is trying to invoke the process environment block, find the being debugged flag, whether it's switched on or not. Usually it's considered as a smarter approach than using the isDebugger_present API call. But I believe EDRs and AVs are now also detecting this kind of standard technique now. And the fourth, very last evasion technique, it's using getCurrentProcess API call, which is basically trying to ascertain whether the process is running as a 32-bit process within a 64-bit Windows OS. Again, this is a questionable technique, since all Latrodectus payloads are 64-bit DLLs, and they would almost certainly always run as a 64-bit process. But again, I believe this is also trying to counter some emulation scenarios, maybe even some sandboxes. All right, let's look at some of the anti-analysis techniques. The very first one, it's using runtime API resolving. Again, I would say nowadays this is pretty much standard. The Latrodectus payload is invoking the process environment block, trying to find the base address of kernel32.dll, anti-dll.dll, and basically using load library W to load those libraries. There's also API hashing, and basically Latrodectus is invoking the system32 folder, finding specific file names, DLL file names, and comparing the file names against the CRC32 hash values. The same goes for the actual exported functions of those DLLs and libraries, so it's a basic comparison check, and this is how it gets resolved. Now, the very last technique, the string encryption, which is to me the most interesting part. So until version 1.14, there was a distinct technique, or let's call it algorithm, how it was using a string encryption. And to get into the details, so all strings that were encrypted within the malware payload were stored in the data section, and the first 4 bytes of each chunk or each string were used as the XOR encryption key, but also served as delimiter bytes. The 5th and the 6th bytes are used as the size of the actual chunk over the string, and whatever is left after that is basically the encrypted strings. So with that algorithm in mind, we could create a short Python script, iterate through the data section of each Latrodectus payload, and get the final plain text strings. Up from version 1.4, the XOR encryption was changed and basically switched over to AES encryption. There was also a hard-coded key inside each Latrodectus payload, and doing the decryption in CTR mode. I wanted to basically compile a master table with all the changes. So this is how it goes. I just want to go through it quickly. The very first one, XOR encryption, first 4 bytes serves as key. Next 2 bytes are the data length, and whatever is left after that, it's the data. All seeded, or actually, yeah, mutate the seed via the PRNG function. The next versions were switching to rolling XOR and downgrading from the PRNG using just an incrementer, but the same algorithm. And finally, we get to more recent versions of this family where the encryption scheme was changed to AES, to 5.6 in CTR mode. And here the algorithm changed a little bit. Basically, the hard-coded key was used as the key. First 2 bytes of each chunks served as the data length. The next 16 bytes were used as the IV, and whatever is left after, that's the data that we need to get. Okay, some of the smaller details. So whenever Latrodectus is active, it sends out the very first network request to the remote server. It contains a GUID. This is basically a serial volume ID multiplied via a hard-coded value. This also serves as a very good detection point because this has not been changed ever, and this is consistent across all Latrodectus samples. The next thing, it also sends out a group ID in the network request, which is basically a FMV1A hash, and yeah, you can find it in the code. The campaign name is stored as an encrypted string in the config, and that gets decrypted, and then the hashing function applied to it. Then we get the decimal value, and that's being transmitted to the remote server. So now I had lots of Latrodectus PCAPs and traffics, network traffics, and so it occurred to me that if I don't have the decryption and the algorithm yet, maybe I can find some different ways to get the campaign names. So I thought, okay, let's brute force this. Let's try to create a word list with the English alphabet and basically apply the FMV1A hashing function to all the generated words. And yes, we can easily brute force this via a Python script, for example. Do you mind that FMV1A is a 32-bit space, so there might be collisions, but for this small research, I think this is perfectly acceptable risk. All right, so I have the brute-forced campaign names, IDs. I could basically come up with some statistics, and it turns out there was this specific campaign called Mimicast, which came out on top. This was the most distributed Latrodectus campaign. Now comes the self-deletion, and so yeah, I also and my colleagues at VMRay we are very eager when we get ourselves some new malware family that we did not discover before, and we're always trying to find interesting features of that malware, trying to create new detections for those specific features. And so Latrodectus introduced this interesting self-deletion technique, which we've investigated, analyzed, and created detections for. And after some time, it was clear that this was coming from an open source GitHub project from Lloyd Labs. And the technique is very simple. It's been known for some time. Basically, you open a handle to the process that you want to delete, or the file that you want to delete with delete access. Then use the set file information by handle API call to just rename the main data stream, close the handle, open another handle to the process, and set the delete file flag of this class. You close the handle, and the file of the current running process magically just disappears from the disk. This technique was working until Windows 11 24H2, where there was a patch from Microsoft which sort of broke this technique, but a simple fix is available. You just need to include a new flag into the code, this flag POSIX semantics flag. All right, as I've mentioned before, Latrodectus partially also works as a backdoor, since when it's executed, it stays dormant and silent for some time, but it can also receive commands from the C2 server. There are almost 20 C2 commands with different IDs. And I will probably group all these into 3 chunks. The very first one is the 2, 3, 4 commands, which are sort of functioning like an enumeration, reconnaissance commands, getting some information from the victim's host. The second batch is more like maintenance commands, like updating the bot, terminating, killing the process. And the third branch is for downloading next stage payloads, getting new shellcodes or DLS to be executed on the host itself. And now we are getting to a point where we know all the small details about this malware family. Basically, we can create a Python script, get all this information and nicely present it. We can get the C2 address, the version ID, mission ID, campaign names, keys, AES key, the RC4 key, which is used for sort of encrypting the network traffic as well. So again, we can do some small investigation with the C2 addresses. So as you see, there's endpoints at the end of each C2 server, and the early versions of Latrodectus were using /live, /test, /drive as endpoints, but more recent versions are all using the /work endpoints. And as I've mentioned on the previous slides in the C2 command section, that Latrodectus can pull next stage payloads and next stage shellcodes. And these are the top 3 shellcodes that we've seen being pulled down from C2 servers. The very first one is the sysinfo.bin, which is, again, functioning as a reconnaissance module, executing commands like netuser and similar, getting more information from the host, basically. The next one is a stealer module, the stkm.bin shellcode, which is getting browser cookies, saved credentials, login credentials. And the third one is very surprising to me because I did not see web injects being that active nowadays. So this was, again, an interesting observation that Latrodectus can pull a shellcode, which is basically a web inject targeting specific banks and pulling the credentials from the browser. Now, with all the C2 addresses, we can also do some investigation into the ASNs and the distributions. The biggest chunk of the C2 servers were inside Cloudflare.net, but this might be a bit misleading because it's not actually the Cloudflare, it's the network behind that. But if we look at the second biggest branch, which is the Metaspinner ASN, this tells a different story. You can look it up on, for example, URL House. They collect information on this ASN. You can see in the past it served not almost, but over 2,000 malware sites in the past, of which 250 is still online. And yes, Spamhaus also provides an information that this ASN should not be peered with or routed with because it's under cyber criminal control. I've looked up their website, and again, this tells another story that it's some shady business. They promise some very high SLAs, 200 plus networks peered with, which is a lie because I've looked up the actual peering information for this ASN. They only have one peer to an upstream ASN. So this is just a shady ASN or a business. And finally, I want to give you some takeaways and some conclusion. The first one is detection opportunities. So this is very contradictory for me always with malware, especially with Latrodectus, because they go to a length where they implement such advanced techniques like walking the process environment block, implementing some evasion techniques. But on the other side, there are still static values in Latrodectus which all serve as good detection points, like the mutex or even the user agents. These are all fixed in all samples of Latrodectus, still serving as good detection points. The other thing is there's the hard-coded AES key, which is again static and has been consistent in all versions of new Latrodectus samples. And there's also a specific part in the code where the exact version is marked. So again, with the Yarrow detection or Yarrow signature, you can easily anchor on that and use it as a good detection rule. Let's talk about a little bit on activity and survival. So I'm sure you've seen the news in May 2025 where law enforcement came out and basically they've taken down around 300-something servers, all malicious infrastructure. And I've tried to basically match that against our own telemetry, and it tells the situation in the picture perfectly that in May or after May, there was a clear drop in activity of Latrodectus. But right after that, some weeks and a month later, we see a small spike and again, some increasing trajectory of distribution. So we can say Latrodectus has survived the takedown and still being developed. The takeaways, I want to give you 3 points. Very first one, there's a new delivery technique now. So we know Latrodectus is experimenting with trying different methods, different delivery techniques. The second one, quick versions. So there's lots of new versions nowadays, small changes across these subversions, but it's clear and tells the story that Latrodectus is actively being developed nowadays, even after the takedown. And the third one, as I detailed it previously, still very contradictory for me. There are lots of good detection anchor points to detect this malware family. So send this information to your SOC or CERT. They still provide good detection. So for me, the only question is, will we get to version 3.0? I'm sure we will in a couple of months. So I'm going to keep half an eye on this malware family in the next year as well. And with that, I want to thank you for listening to my talk. I'm happy to take any questions here now or in person later on the floor.